Hey, happy Thursday. We're going to jump right into Number Corner today because today we're going to be doing a problem string. And we know problem string sometimes takes a little bit of time. And so in order to get everything in, we're going to get started. I am going to show you today's calendar marker, but we're not going to fill out the observation chart together. The next time we come back to Calendar Grid, then you will see the updated version of what that calendar marker looks like in terms of money, fractions, and decimals. And then I'm very quickly going to show you Race to the Millions before we start our problem string. So here is our marker for today. It is, this is actually for the 21st, so it's not Thursday, excuse me, it's Wednesday. Miss Tramel's getting all her days mixed up. So we have some money here. Take a close look. Are you good? All right. Now we're going to update our Race to the Millions. Today is Miss Tramel's turn, so she's going to spin. And I'm going to zoom in to make sure that I'm seeing what I think I'm seeing here. Does that look like an 8 to you? I think it's an 8. So I am going to put my 8 in the, you guessed it, 100,000s place. So now I'm adding 800,000 to my number. And what I get is 1,736,220. So which one's bigger? 1,736,000 or 1,644,000? You got it. 1,736,220 is bigger. Miss Tramel is catching up, and now she's beating you guys. Told you this game turns around quickly. All right, so now for our problem string. Go ahead and turn to the next available page in the back of your Number Corner journal so that you can work through this problem string with me. I will say you can use some of the strategies or think about some of the strategies that we've done in other problem strings to help you solve some of the problems that we're going to encounter in today's problem string. And I will tell you that this is actually our last problem string for this month for Number Corner. So let's make it a good one. So here we go. Let me give you a little bit of context here. This summer, I took a group of students to the water park, but really not this summer because we know COVID's going on, so just pretend like this happened. Our passes cost $7 for each student. We need to figure out how much it would cost for our whole group, okay? So when they were trying to figure it out, they started by figuring out how much it would cost for 2 students to go to the water park. The passes are $7. How much would it cost for 2 students? So the very first thing I'm going to do is I'm going to label my ratio table here. So you need to do the same. We have number of passes, and we have the cost per pass, or the total cost, I'll say. Okay. And you may remember that I've told you when we are filling out our ratio table, we should always start with how much one costs. So I'm going to add 1 to my table. And I'm actually going to draw it in. Let's use blue. So if I have 1, how much does that cost? $7, okay? But my first question is asking how much would it cost for 2 passes? So now I have 2 passes. How much is that going to cost? 2 times 7, right? Which is 14. You got it. All right. Remember, our problems are going to get progressively more difficult, but the goal is not just for me to know that you know your multiplication facts, but I want to hear about some of the strategies that you're using to solve. So let's look for the next problem. All right, so let's see. Oh, I guess I gotta make it smaller. All right, so now my neighbor has 3 cartons. Ooh, I'm on the wrong problem string. I thought that looked a little funny. Okay, so let's look at the first one. Now I want to know, what is the total cost of 4 passes? Now I have 4. So how much is that going to be? What's my, it's 4 times 7. How can I solve that? Right. So each time we're now doubling a factor. Remember we talked about doubling? So when I double a factor, I have to double the product. So what's 14 doubled? You got it. It's 28. Good job. All right, let's look at the next one. What about 8 passes? Still easy peasy, right? Yeah. So now I have 8 times 7. So what are we doing again? You're right, we're doubling it again. So I'm going to record that. And what is 28 doubled? You got it. 56. All right, let's see what the next problem is. We are rocking and rolling with this problem string. How about 12 passes? Yikes, now we're going from 8 to 12. How can we use what we know for 12 times 7 from what we already have on our ratio table? What can we do? Yeah, 12 times 7 is the same thing as saying 4 times 7, which is 28, plus 8 times 7, because 4 plus 8 is 12. So I am going to erase this because you guys know we're doubling so that I can record what that looks like, what we just did here. Okay, so we now have 4 plus 8. Which means 12 times 7 is going to be 28 plus 56. So go ahead and figure it out. What is 28 plus 56? What is that going to be? I know, at 28 looks a little funky. So what'd you get? Yeah, 84. 12 times 7 is 84. I think you guys are really getting the hang of these problem strings, and I love that you're using strategies to help you figure out the problems by using some of the earlier problems that we've solved to help us figure out some of the next problems. So let's see what's next. Ooh, 20 passes. Yikes. Now, I know it's asking for 20, but what can we add to our ratio table to kind of help us figure that out? All right, 20, think about splat, okay? We can break 20 up into what 2 factors? 2 times 10, right? So that means maybe I need to add 10 on my ratio table, even though that wasn't a problem given to me. And I easily can do my tens. 10 times 7 is 70, right? It's growing by a power of 10. So my place value is shifting. So now that I have 10, can I double that for 20? I sure can. So what is 70 doubled? Yeah, 140. You got it. You guys did it. You're doing an awesome job. So we just doubled. Remember, when you double a factor, you are doubling your product. All right, let's try the next one. Ooh, how about 19 passes? We can solve that easily, right? Yeah, because what do we know about 19? Right, that's one less person, which means one less $7 that we have to pay for a ticket to a water park. So technically I'm subtracting one pass, and that means I'm subtracting $7 because one pass is $7. So what would I get then? Minus $7. What's 144 or 140 minus 7? Yeah, 133. Kiss your brain. All right, let's see what comes next. What is the total cost for 16 passes? Yikers! Take a moment, pause this video so that you guys can work through how you might solve the cost of 16 passes. What could you use from our ratio table to help you figure that out? Pause this video. All right, so you're back. So how can I figure it out? What can I use? Did anybody use 8? And double 8, if you double 8, and I know my arrows are getting kind of funky here. If you double 8, you get 16, which means if I double 56, I should get the product to 16 times 7. So, what's 56 doubled? What'd you get? Awesome. 112. Everybody give yourself a bow chicka wow wow. We did it. Good job. Good thinking. 2 more to go, I think. Yes. Let's see. Ooh, now we have 17 passes. That should be easy, right? Go ahead and work it out. Fill it in. All right, if you hadn't paused the video, go ahead and do that now. All right, so how do I get from 16 passes to 17 passes? Essentially, I'm just doing what? Adding a pass, right? Adding one pass, which means I'm adding how much money? Good, one pass is $7. So what is 112 plus 7? You got it, 119. You guys are rocking today. All right, last one. We can do it. So if you stuck with me this long, great. And make the effort to stick with me just a little bit longer because we're almost done. Let's see what the last problem is. Ooh, 29 passes. 29 times 7. Pause this video so you can work it out. How can you figure out 29 passes? What do we know? Okay, I'm going to give you a hint, okay? So I'm going to draw a separate ratio table down here. I'm going to add a couple lines, and we know we have the same kind of thing going on where we have 10. Well, I'm telling you, we have number of passes and the total cost still. Now, I really want 29, okay? So one way to get to 29 is by using 20 plus 9. But do we have 9? We don't have 9. We have 10, and we can use that 10 to figure out 20, which we did earlier, and that was 140. But I need 20 plus 9. So I'm going to use my 10 to figure out 9, because that means I am subtracting $7. Okay, so 70 minus 7 is 63. It's another good reason for you to know your multiplication facts, by the way. So now if I want 29, I could do 20 plus 9. You guys following all my marks here? I know I have a lot going on today. We had a lot to add to our ratio table, which means I am adding 140 plus 63. What's that going to give me? 203. And 3 looks a little funky. Good job. Now I'm wondering, with all the work that we've done with our problem strings, if I were to ask you to solve a problem like 8 times 26, how could you use a ratio table to solve that? Pause this video and have a quick discussion with your teacher, with your classmates. Right, I want to hear about it. What are some things that you could do? There are a couple things. And I don't like that line. There are a couple of things that you could do. We always start with what? With 1. So we can have 1 times 26, and then we can continue to double and do 2 times 26, and then 4 times 26, and then we can get our 8 because we can keep doubling a factor, and that's doubling our product. And so this is what it would look like. 1, 2, 4, and 8. We have 26. We would have 52, 104, because I'm just doubling. And so then that would be 208. Is there another way that you could have done it? Think about what we did with our 29, where we did 20 plus 9. Yeah, I could do the same thing. So maybe instead of having the top, well, here we did a number times 26. So 1 times 26, 2 times 26, 4 times 26. Maybe we would start with 26 and figure out that times 8. So in that case, it would be 1 and 8. See where I'm going with that? And then we would do 2. What would be next? I could go to 6. I could double it, 4, and then add 4 plus 2. I'm just going to go to 6, which means I tripled. Okay, 6 times 8, 48. So you can triple. You don't have to just double on problem strings. Now that I have 6, if I'm really trying to do 26 times 8, then what am I going to do now? I need to get to 26 up here. We have 6. We need 20, right? And what do we normally start with before we get to 20? We start with 10. So I could do 10, which is 80, which would then give me 20, which is 160, right? And so then if I want to find 26 times 8, I would just add 20 plus 6, which still is going to give me, guess what? 208. So you guys are going to be using ratio tables to solve more problems this school year. So just because we're done with ratio tables for this month doesn't mean we're done with them for good. Great job today. It's Wednesday. I know Ms. Trammell said happy Thursday, but it's actually Wednesday, so I'm sorry about that. It's been a long week for me so far. I hope it's not been as long for you, but I hope everything's going well and that you have a great rest of your day. I will see you tomorrow. Bye.